I don't know. We'll see. We've never asked, and this is good. So, all right. So one of the things that water is our main carrier, and so you have to appreciate. And I want to give you just a little bit of science behind it, which is about all I can do. Bill is more of a chemist person, but from my perspective, people just treat water like it's nothing. It's just water. Well, it's not just water. Water is not pure. Water has a pH. It's got calcium. It's got magnesium, and actually, it's a very, very complicated molecule. And the only way that I explain this, because of my limited knowledge, is I always ask people, if this was a magnet, what attracts one magnet to another? And it's opposite charges. And so this is pretty important with water. And I'm going to show you this one here. Why?
Joanna.
And I'm Steve.
And this is a piece of PVC pipe.
And this is a plastic cup that has a hole drilled into the bottom of it. So when I fill it with water, it leaks out of the bottom.
If I charge the pipe and then bring it close to the stream of water, the water is attracted to it. That's because water molecules are polar molecules.
Water molecules.
So that's just, it's got a charge. Now, if I did it on my head, nothing would happen, but at least she had hair to make it move. Folks, that's pretty important, because when water comes in, I want you to look at the shape of every single water drop. Big, little, on the leaf, flying in, or what have you. You can see it coming in, and we're going to repeat it. You can see little drops. And I think, Stephanie, if it ever comes up, I think that laser pointer shut out my ability to move it. That's why I'm not going to, we'll just keep it now that it's working, to move the video. You can see every single drop there, folks. It's perfectly round. Okay. Now, I don't know what happened here, so let me go back. Technology is not always my friend. So, Bill, is it a true statement that every herbicide has got to get to the leaf surface to work, and every herbicide has got to penetrate a little bit or a lot in order for it to work?
Yes.
Okay? Now, there's a whole science to that. You don't need to know any more than that. At least I don't. So what you're seeing here is a hairy leaf, and I don't know of that particular plant that we're talking about, of some of these cover crops, if they're hairy plants. And if they are, then a potential failure could be something like this. So what you're seeing is the water drop that's evaporating with the chemistry. And it's not going, that's not a, unless somebody tells me different, Bill, those wax hairs they don't move anything in. It's just a piece of wax. Is that right?
Yes, that's correct. A lot of times they're very high in silicon content.
Okay. So what's happening here is, on a hairy plant that you're trying to kill, when this happens, you're diluting your chemistry. You're diluting your tank, because not enough of that product is reaching. So water's got a charge. It always wants to be round. Do any of these have waxy surfaces, Stephanie, of the things that we want to kill? Again, I don't know, so I'm going to defer to you. So does water and wax mix? Does water and oil mix? The answer is no. Now, what you're seeing here is when this product, Bill, what I'm trying to show is when that water evaporates, it leaves behind this material behind. And I always say this is not good. You would like to have it penetrate. Is that a true statement or not? And if you disagree, please disagree, because I don't like to have stuff left on the surface, right?
Right. Particularly, you don't want it to dry on the surface before it's absorbed, because then it needs to be re-wetted in order to penetrate the cuticle.
All right. So now I've got this problem of trying to penetrate something that water doesn't want to penetrate. So we've talked about temperature already. Now what I want to talk about is minerals in pH. This is a real, this came out of Michigan. The well water was hard at 250, and I'm going to show you how to make these measurements. It's real easy. I always say water around 200, 250 is beginning to get hard. 450 is really hard. The water pH of this one is 7.8 coming out of the well. So it's on the, on the alkaline side. If I collect out of a gutter, it's got 0 hardness because it hasn't had a chance to get on the ground to pick up the calcium and magnesium to make it hard. And then the water is acidic. This is why if you're old enough like me, it was going to be acid rain that was going to kill us and everything around us. And it's true. It is acid coming through the environment. All right. So hardness and pH are 2 factors.
Hardness is just a term that we just generally throw out there. I mean, it's just a general term, and it talks about how much calcium, magnesium, and those like kinds of elements. And I can't see that in here. Distilled water is meant to pull out those products.
Distilled water is supposed to be the absence of any of those dissolved solids.
Okay.
Total hardness is right here at the top. It's the blue one. And this one shows 0 total dissolved solids, which is what you'd expect from distilled water.
That's the blue
Again, you
line,
match up the
the
color.
top line.
There it is.
Which one of these have got some good hardness
Oh,
in it?
this one's a bad, nasty.
Now,
Remember?
yeah, so
That's the water that came out of our tap.
this is coming right out of drinking water, and we're going to look at hardness. And if you notice that this is a very vibrant purple, the first line where I see total hardness, and I'm just going to match up the color, and it looks like it's almost a perfect fit. And I can see some, yeah, so it's between 200 and 400 parts. So would that be very hard water in your case?
It is. It's hard water.
The reason this is important is this is just another factor along with pH that controls how well it's going to work.
Okay. So we're going to talk about hardness first. So let's just see what's taking place
Taking
when
a
we
look
mix something like
At the
glyphosate
water, you notice,
into hard water with
water
calcium
quality.
and magnesium.
as we look at these, which of those is hard? This isn't glyphosate, but it mimics glyphosate in a hard water environment. And we'll put a little bit in here.
And Bill, is it, and I guess I'm asking you, glyphosate is
We'll
one
put
that
the same
actually
amount
dissolves in
relative
water, right?
here.
It goes into solution.
Yes. Yes.
Okay,
Those
so
2 spray solutions.
if it
Otherwise,
dissolves completely
that
like that
material-
first jar, that means whatever I did, that's a solution because I
You'll be
can
able
see
to
through it.
discover pretty quickly
Yes, that's correct.
So look what
which of
happened here.
these is having a reaction. Glyphosate has reacted with the calcium that we artificially hardened this water with, and now that's a completely different, larger, molecule. For every molecule of calcium, it's tied up 2 molecules of glyphosate. That's hard water antagonism. So the glyphosate is completely available here to work at the plant surface. And when this application happens, 100% of the glyphosate is going to be out there working to impact weed control. Here, because you've had a reaction, a percentage of that glyphosate is tied up to calcium, put the same amount of material in, and yet you've got much less of the same molecule out there working to kill the weeds.
So if you have hard water and you're using glyphosate, and I guess, Bill, that's the poster child of this, but I'm sure there's other products on the labels. And I get it bound up, and I'm going to show you what that means. And it doesn't go into solution. I have diluted my tank.
Yes, you've definitely decreased the ability of that plant to penetrate the cuticle. The question really becomes what happens to that glyphosate when it hits the leaf surface? Does it still stay complex with the calcium? And
Yes.
and in most cases it does.
So and then what I've learned from you guys is that molecule, because Roundup is what, is systemic.
Yes.
And so it's too large when it binds with calcium and magnesium. My understanding that I can't move as much through the plant, into the plant.
Yeah, it's less, yes, it's less soluble in the plant cuticle, so it's more likely to accumulate on the surface of the cuticle. See, another way to think about it is only about 20% of the applied glyphosate gets into the plant anyway. So anything you do to reduce that 20% down to 17% or 12% or whatever it happens to be is going to reduce its ability to kill the weed.
So if I'm cutting rates, which I anticipate, and I have hard water that I don't fix, I'm really stressing these products. And again, I would expect to see less control. So what Norm just said, a diagram, is what magnets are attracted to each other based on charge. Calcium, magnesium, an example. When you put Roundup in it, Roundup is a minus molecule. I always say that the pluses and the minuses want to average out to where for every plus you have a minus. And so when you put Roundup in the hard water, this is what takes place. Calcium grabs two of the glyphosates, and now it's too large. And as Bill said, 20% gets reduced down to how hard your water is. Here is one that let me get it here, that Lisa would know. This is one without mentioning names, Lisa. This is Tom's. This come out of Tom's well. And is that hard? That sucker is really hard. I'm surprised it even pours. But here is an example. In Indiana, our water can be extremely, extremely hard. Okay, so let me click on. So I'm just trying to bring the facts before we start looking at this, at the science here. So this was a talk that I did for a group of farmers around the Midwest, and they took some samples for me. And so begin with this Kansas 1 and 2 are the same farm, different wells. Can you see the difference in hardness or these numbers? And I'm telling you, 200 starts to get hard. 1400 is extremely hard. And you can see here, just as an example, in other parts of the state with single samples, what it looks like. And you can see the pH range here of the products almost always being in the alkaline side.
What the industry calls a water conditioner. This material is going to affect the pH. And
so we're going
to
to add something.
Take the water hardness, which remains at that same level.
To fix that hardness here.
The equation, it's going to tie up the calcium, and it's going to allow that glyphosate molecule to come completely back into solution and be available for weed control. A quart per 100.
I'm more interested in you seeing look at the jar,
that reaction,
and watch what happens in the jar.
Glyphosate. That reaction is now being displaced by a new reaction, and that water conditioner is actually taking the calcium that tied up the glyphosate, and it very efficiently and effectively reverses that process. And the only thing that it changed on here.
Did you notice that the bottle cleared up? So this is why we're using things like the question, ammonium sulfate or these other products that substitute for the ammonium sulfate. It cleared up, which meant, Bill, in my mind at least, that whatever was there that was not in solution now went in solution because it's clear. I'm not sure if that may be too simple of an explanation, but that's the way I understand it. So what happens when you add ammonium sulfate or the negative or the alternative products? It's the sulfate, which is the double minus magnet, and you see here it wants the double plus to end up being, they offset each other. And so what it's ammonium sulfate says, sulfate, Roundup, get off of here, and I'm going to bind to magnesium. And then it's going to release the, as you can see here, the minus glyphosate, and it's going to attach to the ammonium ion, which is positive. So what I'm doing is rearranging the products. And I think, Bill, in your world, it's still not explained fully yet, I guess, but that apparently that ammonium ion is that it's something important in transferring the glyphosate into the plant. It helps me.
Yeah, it makes it makes the glyphosate more soluble in the cuticle. So
Okay.
what you want a neutrally charged molecule that is somewhat soluble in an oily mixture, and that will enhance its ability to get through the cuticle. And that's what. So for many weak acid herbicides, glyphosate is one of them, but 2,4-D, clethodim, and some others are also weak acid herbicides. They respond the same way to ammonium sulfate.
Now, Bill, I'm going to make a statement. I haven't thought about it maybe enough. This stuff is cheap enough that if I am cutting rates, I'm
Go ahead.
going to clean up my water with Hardness, no matter what my products that I'm using. This has no impact on my products negatively. I believe, though, if I could clean up my water, I'm better off, especially if I'm trying to cut some rates and not knowing what might happen to these other products.
Right. So when we think about, both glyphosate and glufosinate or Liberty, both of those herbicides benefit from from having an ammonia source in the spray water. So even if you don't have hard water, having a nitrogen source through ammonia helps both of those herbicides penetrate plant cuticles. And cheap may be a strong statement on ammonium sulfate. I don't have a good feel for how much ammonium sulfate prices have gone up, but my guess is they've gone up as well because fertilizer prices have gone up.
Well, it used to be, I think, 30 cents an acre or 50 cents an acre but that was in the good old days. So you're right. You're right. But if I'm cutting, trying to save money on one end, maybe I can fix it here. Now, the pH and Bill, overall, outside of a handful of products, I'm going to show some more of your data. Overall, pH is more an insecticide problem, I think, than it is with most of our products. But most of our herbicides like to be in acidic water. Is that true?
Correct. Yeah,
Why,
anywhere from about 4.5 to 7 is 4.5 to 6.5 is where the activity of most herbicides is going to be maximized.
okay, so I hope all of you heard that. So let's just say 4.5 to 6.5. And so what I want to know is, so you can see the pH. So what Bill is saying for most, and I'm going to show you some that's not, but for most, Bill, you would like to be into this 4 or 5 tomato juice, orange juice, acid. That's why you call them, I guess you call them weak acid herbicides. What I want to show you here, and it's sort of a trend, as you go from a pH 5, 7, 9. So I'm going from acid to neutral to alkaline. What you're seeing in orange is how long for half of the chemical to disappear. Break down, whatever you want to call it. I cherry picked. I'm trying to make a point here. So as I go from for most herbicides, actually most products, as I go from the pHs, I go to alkaline, I am losing a lot of the half-life on that product. Y'all see that? So at pH 9, 10 minutes instead of 16 days. That fungicide, 9 is 2 minutes. Time I mix it, take a smoke, it's a half of it's gone instead of 10 hours. 24 hours at a pH of 9, at pH 5, they're stable. So alkaline water typically hurts us. Now, what I'm just showing you one. I know you probably can't, if I can figure out how to do this, but these are swimming pool test kits. You can buy them anywhere. If you've got a swimming pool, I've got pH and hardness are important components to a swimming pool, no different than our chemistries. And so you can see here that the hardness is the purple, and it's just litmus paper. And the pH, come on, Fred. The pH is the second one here. And so I can actually measure. Don't need to look at the chart to read it, but this is a mixture of chemicals. This came from Winfield, and obviously they sell these kinds of products to fix pH and hardness. But you can see all of the red that's listed. And if you looked at the alkaline, look how many reds you get or yellows. And you have a few that are hurt on when the water is acidic. So what I'm telling you is here, if you don't know what your you don't know what your water quality is, pH and hardness, then there are opportunities for failures. Bill, this was I believe, one of your students in your research. Well, we say that most products like to be in an acid environment, 4 to 6.5, which is what we have here. Do you remember this particular slide? I've used it a lot, so I'll let you talk if you can. You remember what it is.
Yeah, that's from Jared Rosskamp, and that was Sharpen or Safe Flufinicil herbicide. So basically what you see here is that's a herbicide that is more soluble at high pHs. So this one's a little bit unique. And Fred, I don't know what you have for slides after this, but what we found with this was that when you got up into those high pH ranges, the herbicide was more soluble in the spray solution, but it was also more likely, it broke down quicker in the spray solution as well. So it wasn't, you couldn't afford to mess around and let a spray tank sit around for very long at pH 9 if you were going to use this herbicide.
Okay. This is why this is important. And I'm sure, and let's see if yeah. So this is when you go back to the label. Don't memorize. Nobody memorizes this stuff but Bill. And that's sort of sad. But Bill must dream about this stuff at night. Look on the label. And this is the part of the label that nobody looks at. And so you can see here, Bill, do not mix with acidic materials. So I know that Roundup's acidic. And if I mix that one chemical of yours up that we just talked about, that one there, and Roundup dropped it down to 5, that's going to be a bad combination, right? For effectiveness. Yes. Some of the products tell you don't add a pH adjustant. I've had 2 farmers burn corn crop because they took Roundup, which was already extremely acidic, and they really dropped it down and basically sprayed acid. But you can see these magic numbers that appear on the label product. Don't use if it's above 8. So you can see why it's important to know when you're talking to people what the source of water is. And the last one is code. The last one, spray mixture within 24 hours of mixing, because what they're telling you, this stuff's breaking down. So look on the label. And so I'm going to show you how to measure pH.
These kind of easy strips.
For example, this is distilled water that we took right out of a gallon container.
Yes.
Just did that about 20 or 25 minutes ago. And you'd think that the pH might be neutral. It's not. It's on the basic side. Pull it out. Give it about 10 seconds to react. The pH line right here, the third one down. So you just line up the pH color.
So the pH is color up.
What's most representative? You can see 7.5, slightly basic, 7 being neutral.
Mm-hmm.
This is a base solution.
Now look at the hardness. It's that blue color. So 0, roughly 0 hardness, about 7, whatever that is that he said. So on the face value, Bill, and I'm going to go a little deeper, this would be poor quality water for most of our herbicides. This would not maximize that product. So what I'm going to show you here is, and again, I've got 14 different kinds of test kits. I'm going to pull out the strip. I'm going to do this. This is all there is, folks. I'm going to, as you're seeing here, I'm going to measure the pH and the hardness, and the hardness out of the water here at Purdue. Let me make sure I line it up. Is purple. Our water here On hardness is about 800. Extremely hard water. This would be a killer for Roundup. My pH water here is a pink. It's about an 8.4. So just like that, I can determine my water. Horrible water, good to drink, bad to spray with. Folks, these test kits give me all the information that I need. I wish you guys gals would buy some of these, so when you go out, farmers have an interest in some of this. It's a way of explaining. You can see here it comes from this was a pet store. You can see the pH down here is about a 9. This is horrible water, and you could see the hardness is in that yellow. This not very hard. What I'm more interested in, Bill, and I'll be interested in your opinion on this. I don't care what my water is to start with, because I know that some of these chemistries drop my pH and some don't. So I know that anytime I use, at least I wanted to say Monsanto or Bayer's, what we call premium products and all that stuff, loaded, I think it was the old adage, that when I add glyphosate to water, it drops that pH down to 5, always. Is 5 a good number for Roundup?
Yes,
That's great.
yes, that's why the manufacturer formulates their products that way.
Now, I don't know, Bill, I don't know if all products that have glyphosate do that. I've had a couple that did not, and I was surprised. I don't. It's maybe a way of cutting money, but I don't make the assumption, and you agree or disagree. I wouldn't make the assumption that any product does that of glyphosate.
Yeah, I think that's correct. I think more often than most of the ones that you buy actually have the pH adjuster in it. But, like you said, the pool test kits are so cheap. If you have any questions about it and you bought a glyphosate product that you've never heard of before, then you might want to check it.
Good. And then 2,4-D, again, this was up at it. We did a field day. We did the 2,4-D, the tap water. This was actually measured at a lab. You don't need to do that, but that's why it's so precise. But that 2,4-D, then you can see hardly change the water. So, Bill, if I was going to try to juice up this product, if I was cutting rates, would you try to acidify it a little bit more, or would you be okay with that? Again, we're making this. Go ahead.
With glyphosate?
No, with 2,4-D.
Good question, because the evidence with 2,4-D, it's less impacted by spray solution pH than glyphosate is. But since I know what the pKa of 2,4-D is, I know that if you drop that pH closer to the pKa, that it's going to increase its solubility in the cuticle.
So is the answer yes or no? Since I don't know what you're talking about.
Well, it depends. No. The answer.
Yeah. So folks, that little test strip can tell you a lot. But what I'm interested in is not what my original pH is in the water, like I just did with my cup here. I'm interested in what I put in, because if it stays up, if my pH is 9 and I put 2,4-D in it, it doesn't move it. I would like to acidify that water to get it into that acid range, I think, to improve performance.
Yes. Yeah. Are you going to talk about the pH effect of AMS on spray water?
I think we're out there right here. We'll do it right here, I think.
Okay.
So what people are confused on is pH and hardness. They think they're related, and as far as I can tell, they're not. I treat them as two separate issues. So let's look at this sample. These are real numbers, and I want you to be able to answer a couple of questions here, because if you're doing this with some of your farmers, they're going to ask the question. So let's look at the pH. The well water was 9. Horrible water to start with. When I added 2,4-D to it, Bill, it didn't alter it. So I'm thinking I could acidify this particular product and make it improve performance. The Roundup dropped at about 5. And okay, that's about what is typical of Roundup, at least what we used. The AMS that we talked about that fixes hardness only drops at about 0.5 point, Bill. And I've
Right.
never seen that change. Never. It's always just about 0.5 point. I can't explain it. It's just what I see. So it does not influence pH. And many farmers believe that it fixes pH and it has nothing to do with it. And then obviously you buy products like acidifiers. We used it by labeled rates at this program, and I can drop it down to 4. Now, what I want to ask you is this. The flip side to ammonium sulfate, the 4th one down, the water was 120 parts hard. So, Stephanie, it's 120 parts when I started calcium and magnesium. It's not very hard. How come when I put the AMS, the calcium and magnesium number didn't go down? Because I saw it work. You can see it clear up. Any idea why? It's like you did nothing.
No, Fred, I don't have an idea.
Okay. So did you actually remember we had the little magnets, the calcium and all that. Did you actually remove the calcium and magnesium from your water?
No.
You didn't. All you did was rearrange it, that the calcium and the magnesium hooked up to sulfate, right? So it works, but you won't see it change like pH because the calcium and magnesium is still there. You never took it out. So I just want you to know that that's going to happen. So here we are, Bill, and let's answer the question now. I will answer it to see if whether you agree or disagree based on what I know, because this is a question you get all the time. Should I add the ammonium sulfate first or last? All right, so my answer is probably twofold. First of all, I like it to be added first, the dry form, not because of this, but because I need more time to beat it into clean water. If I'm not worried about that, Bill, your colleague that was up in the Dakotas, which I think now is in California, I read one of his studies years ago that said it didn't make any difference if I put it in first or last.
Oh, yeah, Richard.
Yes. And,
yes.
and so if that fact, that's the only one I've ever seen, because basically calcium and magnesium are stronger magnets, they can knock that Roundup off. But most people say that don't make sense. I'm going to do it first. Now, I'll defer to your judgment on that, Bill, first or last, your thoughts on that, specifically with glyphosate that we're using.
Yeah. I think if you agitate it long enough, it doesn't matter when you add it in there because your solution is going to reach equilibrium. But I think if you're dealing, if you're in a situation with cold water and you're rushed to get things sprayed, I would want the ammonium sulfate added in there first.
Okay. I don't know if that answers the person's question. It has nothing to probably do with water quality. Hardness or pH hardness. It has to do more, Bill, with timing and trying to get it beat in. Is that what you're saying? Whether you go first?
Yeah.
It would be better to go first, and then we're done and you move on. But it's not because of cleaning up the hardness.
Correct. Right.
So go ahead.
So Fred, I was going to say, maybe in addition to that, I think this question is asking about mixing order, which I think you're kind of hitting on that.
Yes.
Oh, sorry. But what I was also going to say is I also think he's wondering about when you're taking water from your nurse tank, so you're refilling your spray tank, should that be done in the nurse tank or should you be putting the AMS in the spray tank? So when should you be adding it into the mix as well? I
So
think
from
is
an
the other
order
part of that
standpoint-
question.
Okay, so from an order standpoint, I want it to go first because it's going to take me longer in the spring, Bill, to beat this stuff in. It's going to take more time. If and Bill, I have never thought about that question the way she asked it, but I would want to put it into the nurse tank because then I'm going to keep it moving in my tank somewhat. So I think the order would go in first. It's going to take more time, but it has nothing to do with the fixing the hardness. It has with the ability to get it dissolved in the tank.
I agree that, the longer you give it to go into solution, the more likely it is to not fail is the terminology I'd use. But the other thing to think about is ammonium sulfate is corrosive. And so if you can avoid storing that in too many different containers, your containers are going to last longer. So let's say you only put it in the sprayer. Well, then I'm just going to rust out the components of my sprayer and not my nurse tank or tender tank. That would be the only reason not to put it in your tender tanks.
Okay. I don't know, Steph.
Tap water with a neutral pH rating.
Let's get to some more. What I'm going to show you here, they're not related.
pH and hardness are complete. They're important parts of water quality, but completely unrelated in regards to, which it is, hard versus acid or basic. And we both start with the same source. This happens to be distilled. Put it in and you pull it out. You measure the hard, bright blue. You see
The very
that?
top, 0.
No grains of hardness. The calcium chloride. This is like the calcium that naturally solubilizes when rainwater moves through the soil profile, like you'd find in any of your wells.
Norm's going to harden up the water and drive
This
that
calcium
hardness
chloride
up.
Will dissolve, and as it dissolves, it changes the characteristics of that particular material. A couple of minutes, the water quality in this particular solution will change so that this water
Look at the hardness.
is at least 200 grains of parts per million of hardness. Look at pH. pH again is this third line down here, and this is the difference between pH and how they're completely unrelated. The pH comes in at about 7.5. This hardness shows 200. The original strip that we used to measure hardness for the distilled water shows 0 grains of hardness. Look at the pH. It's still going to be in that same
Okay, we didn't move.
7.2 to 7.5 range.
So pH and hardness are the same thing. All right, very quickly, because I'm going to go to 5 and then I'm going to turn this off. Generally speaking, Bill, from a herbicide perspective, making a general statement, would you rather have the one on the right or the left?
On my left.
I think would be all of our left, right? Talking about the
Yes.
one that's all wet, right?
All oily looking, yes.
Yeah, yes, but water can't do that. Remember those drops?
Filling in for our waxy leaf cuticle
Watch what happens.
is a piece of paraffin wax. As you can see, the high surface tension
Water loves itself.
of water makes a droplet repel the substance. And also how the addition of a spreader adjuvant breaks the cohesive forces of the water molecules
This is that graduate student trying to sound
and
impressive.
increases the surface area.
And you can see it spreading on
contact
wax
with
paper.
the substance.
This has to do with adjuvants that Bill
Here
talked
on the
about
left, we
yesterday.
have an easy to wet leaf, such as water hemp. You can see how the cohesive nature of the water droplets create quite a large droplet.
This is impressive here.
And on the right, we have a difficult to wet leaf, like giant foxtail. You can certainly see how it repels water. The addition of a spreading surfactant
So a added surfactant makes water wetter.
increases the surface tension of the water
Now it stays. It's pretty impressive.
On both easy to wet and difficult to wet.
So Bill's point yesterday, he was pointing out in the weed guide and it coming out of the label, this is, you want to be able to break down these drops, Bill, to get better coverage on most things. So when you add a surfactant, it spreads it out, right? I mean, that's what we want.
Correct.
Now, you're saying, well, that's just one of millions of drops out there. And if you think of every drop doing it, there's a reason that the manufacturers put the surfactants on these things, because they know they need that for that product to work better. I was talking to farmers yesterday and they don't buy it. And I said, then you're not maximizing, you're not getting the most out of your product. Well, they said, fine. I said, well, then don't use it. This is that one that we saw without the surfactant, gets stuck in the hairs. When you add a surfactant, it moves through. And now, Bill, I got it on the surface, right? Which is where I want that herbicide to be. So if you're working with somebody and their kill was not very good, get the label. You don't have to memorize nothing, and see, was there a surfactant that should have been added? And or other adjuvants such as Hardness. I thought this was a great video by Winfield. It's an old one now, but you can see on the left that water drop is just rolls off of that plant. I mean, it's just beautifully set up. And obviously it's an advertising piece, but you can see on the Gulf Stream how it looks like it's got a sticker on it, a little bit of something in it, but it's still trying to stay together. And then the one on the far right, you can see that it sticks and looks like it's spreading. Again, they're trying to sell these products, but again, it's a great visual. And the last one, and we'll stop right here, Bill. Sometimes we need an oil, a crop oil, methylated seed oil, to what? Penetrate the surface?
Yeah, it helps to dissolve the cuticle.
Which is strange that some products require it and some don't. So it must tell me that some of these products dry up too quickly, or some products just, because it's still the water carrier. Water in itself doesn't want to go through a waxy layer. So what you're going to see here is, Bill, you've probably used it if you were ever looking at drift. That's that yellow drift paper. And anytime water hits that drift paper, it turns it blue. So what we have is a piece of wax paper on top of it. And if my oil that I'm fixing to put on it can actually eat through that wax, break it up, it's going to create cracks for that water to go in. So I'll speed this up just a hair. Yellow paper, water hits it, it turns blue. Wax paper, I've got to eat through. And what I'm going to do here is show you, watch that white drop. Can you see the blue now just coming in? Look at that white drop. So, Bill, that tells me that I was able to eat through that wax paper with that oil, which is what the oils do.
Correct.
And so, folks, if in fact people are not using the surfactants, the oil, the pH adjuster if it's required, any of these adjuvants, something ammonium sulfate to fix hardness, for many of these products, that's the difference in maximum kill and less effective kill. Still may be good, but it may not be where we want to be, right, Bill?
Yep.
And I keep going back to, if I'm cutting rates and I'm already stressing these plants, stressing the herbicides, then I better have these other things that we talked about correct. Because if I'm already stressing the plant and I knock off little bits here and there, then obviously then it just makes it even worse.
Yeah, one of the discussions I give when I talk about herbicide activity in general is there's 7 or 8 things that make herbicides not work, and about 5 of them are prevalent every time you run a sprayer through the field. So it's an uphill climb to make these things work optimally anyway, and the more stress you put on the system, the more likely you are to have a failure.
Okay. So Stephanie, I think we'll stop there out of respect for you guys' time, for your and Tony's time. So let me stop there and say, I'm going to, first of all, quit sharing so you can get yours up. If anybody has any interest in any of these subjects, we would be glad to mail them the book. If somebody has something for more information or whatever, I would be glad to mail them, or we can make them available online, or tell them where they could get it, whatever the case is. So let me stop there and tell both of you appreciate. I'm sure I'm speaking for Bill, since Bill didn't know he was going to help me with the talk. For Bill and I, we appreciate the opportunity here to speak to you. So speak with you. So.
Well, it's been awesome to have you both here today, Fred and Bill, and yesterday. The information that you're providing to all the attendees is again just really important information, because of the fact that we all interact with farmers all the time, and all of our roles are different. But if we understand the importance of what your role is, Bill or Fred, and then our role, we can be able to communicate these things, but then also bring farmers together with other specialists that know more information and can help that decision-making process for a farmer.
Stephanie, let me interrupt you, because I think this is, I'm going to make that point we started with yesterday. Nobody can know everything that we've talked about. I don't know your world. I mean, I know enough to talk a little bit. I know enough that I want to be a weed scientist when I grow up. I know enough there, but I also have to realize that I can't know everything on everybody's area. So if you're new, you can add little bits. None of us are farmers except for Adam, maybe Hans, that I don't pretend to be a farmer. I'm not a farmer, but I have things that I can offer farmers to make their jobs better, to be more effective. And that's what we try to do. So if I don't know, I say I don't know. And if I'm lucky enough, I've got nobody but me. I still carry this. I look them up. I can look up Bill Johnson's phone number. I can look up most of the specialists, and I do. I've got what I call my Purdue list here, and I call them up from there. So if you can carry something with you and you're asked a question, say, just a second. I have a guest, but let's talk to Bill. I get a hold of Bill or whoever, Jana. Jana, here is the question. What do you think? And people love that. It's like you're making connections, but don't be discouraged. It just takes a long time. So I'll stop there and say, just appreciate you've got things to offer growers, even if you're not a grower.
Yeah, that's well said, Fred. And I don't think anyone could say that any better than you. So I really, really appreciate that. So I actually did get a quick pop-up message to me. Bill, when you said right at the end there's 7 or 8 things that can mess up herbicide efficacy or impact, its ability to do its job. Just for the group here, before we take a break, are you willing to go over those 7 or 8 just really quickly and kind of talk about what they are? I'm guessing it's a culmination of what Fred talked in today, and then also what you talked about yesterday. But if you could just kind of go through them for the group, I think that would be really good.
Yeah. And there's a real good chance I won't remember all 8 of them, but I'll kind of go over them in the order, at least in terms of importance in my mind. So one of them is the stage, the size, the stage of the weed that you're trying to control. That's one. So remember, most of these herbicide labels for controlling weeds are written for weeds that are 6 inches tall or less. All right, so that's a big one. Number 2 would be your weather conditions when you're spraying. So obviously you want good soil moisture, you want actively growing plants, and anytime you have cool, wet, cloudy, or extremely dry, or you're at a time of day where that plant may not have woken up yet, because some herbicides are real sensitive to whether or not these plants they're either woke up in the morning or raised their leaves, because some plants will drop their leaves at night. So that's a factor. So environment, stage of the weed, herbicide rate. So did you apply the right rate at the right growth stage? So that's another one. And again, if you think about all the things that can happen to a spray droplet from the time it goes from the jug to the leaf of the plant, So it can break down in solution. It can be tied up by hard water cations. Once it leaves the nozzle, it can be carried off site by wind. It can degrade in the spray solution. It can miss the plant that you're trying to control if you're talking about post-emerge herbicides, or if you think about weeds growing in close proximity to one another and leaves are shading one another, are you delivering the full dose to that specific size of plant? So carrier volume is kind of tied in with that as well. Are you delivering enough carrier volume to get the right percentage of the leaf that's carried? So I've kind of wrapped a couple of them together. So yeah, so we talked about time of day. We talked about what can happen to the spray droplet. We had talked about what can happen to the plant, and then the application parameters. So each year we get more knowledgeable about which herbicides, the activity of which herbicides that are optimized based on droplet size. So for example, one of the things that you'll hear me talk about a lot, or it may seem like a great idea to spray Liberty and Roundup together, two non-selective herbicides. We have the trait package in corn and in soybeans that allows us to do that. But Liberty is a herbicide that works well with smaller droplets. Roundup is a herbicide that works well with bigger droplets. And so optimizing a spray solution with those two herbicides in the tank together is a challenge. And those are two poster children right there, but there's other herbicides that it's not a good idea to mix as well, just because of antagonism issues. So I think those kind of cover the main ones. So if you think about it, think about the number of times you've been sitting in a sprayer and how many times have you made the optimal spray application when everything has been right. And I would say it's done less than 10% of the time.
So that's why when you think about those things, you try to, those other things, when you talk about hardness and pH and looking at weather conditions and trying to really focus on the stage of the weed, right? So the growth stage, the more that you can look at these things and try to check those boxes off, if there are other conditions that aren't meeting, at least we're trying to address those other things and try to have as much success as possible.
Yep. You want as many of those things in your favor as possible.
Well, that was really, thank you so much for doing that just off the top of your head, ticking them off like that. I figured you had them memorized and just kind of go through those things. And I do appreciate that because, again, I think everyone sitting in the audience today, just, again, how do we communicate these things to farmers? What are the things that we want to think about as we talk to farmers? And those are the things that we want to always continually hit on. Like, are you working with your extension people? Do you have are you doing your own spraying? Who else is doing your spraying? Those are the things that all of a sudden these things become really important. So, Tony, we got time for about a 5-minute break before we pick up. It'll be a 6-minute break, 11:20.